what is physiological approach? Why it is we calling it as a physiological approach? The physiological approach actually quantitate my acid-base disorders by bicarbonate carbonic acid buffer system method, and also it evaluate my plasma anion gap, and it's quantify or measure the secondary response to the primary acid-base perturbations. Okay, if you put all together, I am quantifying the acid-base disorders by my bicarbonate carbonate buffer system, checking my plasma anion gap. 3, I am quantifying, I am checking my secondary response are appropriate or inappropriate. From all these 3 put together, it fulfills the both chemical and pathophysiological task for assessing the acid-base disorders. The first one is a bicarbonate buffer system, second is a secondary response, 3 is the anion gap. Why it is called as a physiological approach? Because it's based on the acid-base physiology, based on the carbonic acid bicarbonate buffer system. Okay. So, first we start with the bicarbonate buffer system. Okay. There is a 3 buffer system in the body. One is a bicarbonate buffer system, protein buffer system, or phosphate buffer system. Okay. What is actually is a buffer? Buffer means a weak acid with conjugate base is called buffer. Okay. So, example, it is a strong acids means it is a HCl. Okay. It will dissociate completely H plus and chloride. It is a strong acid. Weak acid means my carbonic acid is a weak acid. It won't completely dissociate. It dissociate to H plus and bicarbonate. Okay. If example, this is that weak acid. All my weak acids, this is my weak acid with my conjugate base means that is a weak acid, the hydrogen ion removed weak acid. Hydrogen ion removed weak acids are called conjugate base. Here it is a weak acid, it dissociate to H plus and bicarbonate. The bicarbonate is a H plus ion removed weak acid, so it is called conjugate base. This combination of weak acid plus conjugate base is called buffer. Okay. So, if example there is a 3 buffer systems are there, one is a bicarbonate buffer system, second is a protein buffer system, 3 is a phosphate buffer system. Our physiological approach based on that bicarbonate buffer system. Okay. First, before going to see about physiological approach and bicarbonate buffer system, there is 2 principles are very important. One is a law of mass action, second is a isohydric principle. Law of mass action means state that the velocity of chemical reaction is proportional to the active concentration of reactants. If you see here, this is my bicarbonate buffer system. Okay, the carbon dioxide plus water produce a carbonic acid which is dissociated to H plus and the bicarb. Okay, if it is a rate of reaction, if example my patient having high bicarbonate, the concentration of bicarbonate is very high, the reaction will move towards it, convert the H plus, react with the H plus and produce a more carbon dioxide and the water. If my patient having more carbon dioxide, CO2, the reaction will move, goes to this side. Okay. The law of mass reaction is the velocity of the chemical reaction is proportional to the active concentration of reactant. It's called law of mass action. It is one of the very basic understanding about the buffer. It is very important to understand about the physiological approach. Okay. So, if I write this reaction, okay, the K is a dissociation constant. It is a H plus and bicarbonate divided by my carbonic acid. So, carbonic acid I can write like a, it's my carbon dioxide, my carbonic acid I can write like a 0.03 into PCO2. It is a solubility constant of the my carbon dioxide. Okay. So, the H K is a dissociation constant. It is a H into bicarbonate divided by 0.03 into PCO2.